So there's no work that you need to do for part B. Well, you do need to put 300 feet. Don't just put 300, put 300 feet, because it's not 300 meters, it's not 300 miles, it's not 300 inches, 300 feet. Okay, part C. When does it reach its maximum height?
0.
At 0 seconds, right? At 0 seconds. That's at the beginning, right? At the very beginning of everything is when it's at its maximum height. As soon as you let it go, the clock starts. Now it's lower than it was before. So you put 0 seconds. Now here it actually wouldn't matter if you put hours or light years. Light year. Yeah, light year is a measurement. No, that's a distance, sorry. Doesn't matter what, because 0 is 0. 0 doesn't matter. Kills anything off. But put seconds because the formula is in seconds. All right, part D is the part that's going to require some work. We want to know when the ball hits the ground. How do we do that? Set it to 0, right? Set this function equal to 0. That's how we solve part D. So part D, we set negative 16 t squared plus 300 equal to 0. How do we do this? It's a quadratic equation. And there was the class that I had jury duty where I had you watch the video where I went over 3 different types of quadratic equations and how to solve them. And then we came in the next class and I went through it again. This is an example of a quadratic equation where you have your variable squared and you have a number, but you're missing the variable in the middle, right? And to solve this, we use what was called the square root property, which means you try and get this by itself. Try and get that by itself. So I will subtract 300 on both sides first. It goes away over here. I get negative 16t squared equals negative 300. I'm trying to get that t squared by itself. So what should I do next? Divide both sides by negative 16, okay? T squared is, and you're going to have a decimal here. And you'll want to have your calculator. Remember, no phones on the test. Only calculators, legitimate calculators. Which I know I have mine. There we go. 300 divided by 16. $18.75. What now? Square root both sides. Okay, you take the square root on both sides, that'll kill off the squared. Square root here, and whenever you do the square root, you must do plus or minus. Don't forget you're supposed to do that. And so you get t on the left side, and on the right side, on your calculator, you must be able to take the square root of this, which hopefully you know how to do by now. 4.3, 4.3, plus or minus 4.3, roughly. We'll round 1 or 2 decimal places, not that big of a deal. Now, we have 2 answers here, don't we? But only one of them makes sense because one of them is a negative time, and we don't have negative time here. We drop the ball, so we only take the positive answer. So to answer part D, our answer is 4.3 seconds. Remember what it's asking, right? It's asking, when does the ball reach the ground? In other words, how long does it take for that ball to hit the ground, right? It was about 13 years ago. 13, wow, time flies. Okay. 13 years ago, I fell off a 24-foot ladder, And it felt like I was falling forever, you know? It's like my whole life was flashing. You hear that phrase, right? It felt like a long time, right? And but we could solve that problem, right? Isn't me falling off the ladder the same as this problem with that being 24, right? It's all it is, right? And then just do the same exact work, right? And you get an answer. So anyways, all right, that ball took 4.3 seconds to hit the ground, drop from a 300-foot bridge. Okay, number 10, good? Okay. Yeah. All right, so should we just knock out 11 while we're right here at 10? Just knock out 11? Okay, so 11, the only difference is that we are going to take that ball on that 300-foot bridge, but it's going to be thrown up. And the speed at which the ball leaves your hand is 60 feet per second. And then it goes up, and then it comes back down, right? So the difference here is that in our formula for number 11, our starting height's exactly the same, 300, right? But our V naught is no longer 0, it's 60. And it's positive 60 because we are throwing the ball up. If we threw the ball down, then I would put a negative 60 here. So let's change that to positive 60. And now let's answer the questions. Part A says, what's the function? So it's going to look really similar to the last answer, except we are going to have a term in the middle. It's going to be plus 60t in the middle, then plus 300. So we've added this new piece in the middle that wasn't there before, because before that V naught was 0, which killed off that middle term. Now that the V naught's there. Questions? That answers part A. Part B. What's the maximum height of the ball? Now this is the part that's tricky, because if this ball is getting thrown upward, then 300 is not the maximum height anymore, right? The ball actually is going to go up and then stop and then come back down, right? So what are we actually looking for then? Remember, this is a parabola, right? This is a parabola that opens down, right? So if we look at the graph of this thing, it would look like this. We're trying to find the highest point on it, right? Which in this class we called the vertex, right? Now remember, the vertex has two pieces to it, the H and the K. The H was the left and right, right? And the K was the up and down. So if I want to know the maximum height, am I looking for the K or the H? H is left and right. The K is up and down. So actually for part B, I'm asking for the K of the vertex, right? I'm just going to put that here. For this part, I want the K of the vertex, right? I'll draw a picture too. It's like we have this thing, this point, HK, right? HK, and K is the height, H is, hold on, H is this right here, right? So go ahead.
Will we still need to get H?
Yeah, so you can't get K until you have H. I mean, that's the way the vertex works. You have to get H before K. So even though part B comes before part C asks what? When does it reach its maximum height? When, right? So that's actually asking for what? The H of the vertex. So you cannot answer part B until you've answered part C, which is almost like I'm trying to trick you a little bit, right? Pay attention on the test, because in the past, on the test, I've switched the questions. For part B, I've said, when does it reach its maximum height? And for part C, I've said, what is its maximum height? And students will do it the way we did it on the review, without reading the question and understanding what I'm asking for, right? So the when is H, the how high is K, right? All right, so let's get H of the vertex. How do we find H of the vertex?
H equals negative b over 2a.
Yeah, there's a formula, negative b divided by 2a. You need that formula in order to find the H. Now, when we say negative b over 2a, we have to go back and think about this as a parabola, or as a quadratic function. The number in front of our variable squared, that's our a. The number in front of the variable right here, that's our b. And the number that's back here, that's our c, right? That's our a, b, c. And so we're going to calculate negative b divided by 2a using that a, that b, and, well, we don't need the c, do we? So what's negative b? 60, but negative, right? Because our b is positive 60. So negative 60 over 2 times what number? 16. 2 times 16. So we get negative 60 over 32. And then again, we get our calculator out. Hold on. Negative. Oh, sorry, I messed up. Negative 16. Sorry, negative 16, right? A is negative 16, not positive 16. That's negative. So 2 negatives give you a positive. $1.875-ish? Not ish, that's exactly what it is. 1.875. I'm going to go ahead and write it all down because it doesn't keep going. It stops, terminates right there. All right, that is how are we doing on time? 30 minutes left? All right, that's our h. So that's when it reaches its maximum height. So we threw the ball, right, into the air. Clock's going. 1.875 seconds later, it's at its maximum height. So this is your answer here needs to be in seconds. Right? Part C is asking when. When should be a time. Now that we have this answer, we can go find the k of the vertex, right? And how do we find the k? We plug that answer into this function. We replace all the t's with that answer. It's going to require a calculator. So to do this, I'm going to take negative 16. I'm going to take this number, 1.875. I'm going to square it. I'm going to add to it 60 times the 1.875. And then I'm going to add 300 to that answer. Okay, so that's why we have to get h before k, because you need h to get the k, right? So this will be negative 16. Okay, on my calculator, I take the 1.875 and I square it. 3.52, let's say. So this becomes 3.52. And then these, I can go ahead and multiply that right now. $112.5. 112.5 plus 300. I went ahead and just multiplied these right now, okay? My next line, I'm going to multiply these two together, then I'll add that, then add the 300. So negative 16 times 3.52, negative 56.32, and then I need to add to that 112.5 and then add to that 300. I'm going off camera here. So just put all that together. $356.2-ish or 0.1 something. So my answer here is 356.18 or 2. Look, if you get 356, I'm going to be pretty happy. I'll know you did it right. And that's 356 what? Feet, right? This is the height of the ball. This is the maximum height of that ball. Yeah. Yes? Mm-hmm. Yeah, this is the review for the test. So that means that whatever's on here, I expect that you can do during the test. Yes? I'm not sure I understand. Oh, the units? Yeah, I want you to know that your answer actually is measurement of time, and I want you to know that this number is actually how high the ball goes, right? Is that what you're asking also, like the feet or seconds? Or you're just saying, do we have to do a problem like this?
Is there going to be a problem like this?
Oh yeah, absolutely, yes. Yeah, this review, if you can do this, you're comfortable with this, you're ready for the test. If you're not comfortable with this, you're not ready for the test. Yeah.
So question,
Yeah.
when I did this information, my calculator pretty much got the same answer except it had 0.25 and not
Let me see.
0.18. I just input the entire equation with the plugin.
Oh yeah, I rounded. I rounded at some point.
So that's still equal to 100.
Yeah, I rounded. I rounded when I squared this. I rounded, but your calculator did not round. Yeah, so it's okay. Did you get 356?
Yeah.
Yeah, okay. So our decimals might be a little bit off. That's okay.
Okay.
That's okay. It all depends on how you type it in your calculator. Hold on. Yes? No? Okay. Yes?
Can we do number 6?
Yeah, y'all ready to keep moving? Well, we're not done with this problem though. Hold on.
Oh, we're not.
We're not. That was part C. Or sorry, that was part B, right? Part A was this. Part B, we actually had to do part C before B. And now there's still part D. I'm just the messenger.
And are we gonna have a problem like that has A, B, C, and D?
Yeah. Just exactly like this. Yeah. You don't look very happy with me right now. But you have a reference sheet, right? And you know what to expect. Like, there's no surprises here. I'm not going to give you a problem that you haven't seen, right? So you know what to expect. So try and come in and be confident. Like, feel like, okay, I'm ready. I'm ready for this. I know what's coming, right? Don't panic. Just relax and execute the procedures. Well, I'm just trying to help. Yeah. I do think at this level of math, part of it is just like if you walk into the test and you're defeated already, then that's exactly what's going to happen to you. If you walk in, you feel good, you feel confident, like, hey, I can do this, you know, sometimes that's what you need to actually do well. All right, part D. Yeah, part D. When does the ball hit the ground? So what do? We take the original function, this ugly thing, and we set it equal to 0. See, we're trying to figure out how long it takes for the ball to get to the ground, which again, if we're thinking about this as a parabola, the highest point was up here. That was what we just did on parts B and C, right? We figured out how high the ball went, how long it took for it to get there. And now we're trying to figure out when it hits the ground over here. So we want to know how long it takes to hit the ground. Now, unfortunately, it's not that, you know how we got 1.875 seconds is how long it took to go up? Unfortunately, we can't just like double that answer and that's how long it takes to hit the ground. It's just not that way. So we actually have to solve this equation. And to solve that equation, you have two options. You can either try and factor it, or you can use the quadratic formula. I would recommend the quadratic formula on the test because I can almost guarantee you, I'll guarantee you right now that it won't factor, okay? So you will have to use a quadratic formula on the test. Now, the quadratic formula you'll have written down on your reference sheet. It is, well, the quadratic formula says this. If you have a quadratic equation, then the solutions to this are x equals negative b plus or minus the square root of b squared minus 4ac. Remember all this, right? Yes. All over 2a, and actually derived it. Did you ever watch that video? No? You asked about it, right?
Yeah.
Did you ever go back and watch it?
Really late, so
Yeah, you never watched it, yeah. So I derived it on video, but you don't need to derive it. Here's the formula. We get to use it. So we're just going to plug in A, B, and C into this formula based on this information right here. So A for us is this, B for us is this, C for us is this. Numbers are going to get ugly and big, and we're going to need our calculator, but we're just going to take our time through it, all right? So we have here. Now, there is one slight difference here. Here we're going to say t equals our answer because here our variable is t, here the variable is x. So we don't want to put x because we're talking about time, not x here. All right, negative b is negative 60. plus or minus the square root of, so I just did negative 60, plus or minus 60 squared. 60 times 60 is 3,600. Use your calculator if you need to. Minus 4 times A times C. I like to write it that way. 4 times A times C. What's A for us? Negative 16. And C is 300. Oh my goodness, okay, big. All over, the whole thing over, that's a pretty good line. 2 times negative 16. What I like to do first is this. I like to take care of this first. And so I told you all in class, the way I look at it is I count how many negatives I see. And if I see 2 negatives, then it's going to turn to a plus. If I see 3 negatives or 1 negative, it's going to be a minus. So odd number of negatives, it's minus. Even number of negatives, it's plus. So I've got 3600 plus, because there's 2 negatives. And now I just take the numbers 4 times 16 times 300. I don't care about their signs. I do that on my calculator. I get a huge number that I don't like. I get all upset that I have to take this class. I wish I was doing a million other things, right? All right, 19,200. And then I divide all of that by 2 times negative 16 is negative 32. Now I'm going to add these two together. So I just add 3,600 to that. 22,800. Let me continue over here. So equals negative 60 plus or minus square root 22,800 all over negative 32. Now at this point, I am ready to use my calculator to take the square root of that number. So here we go. 22,800 square root 150.99. Wow. How about just say 151? Is that okay with y'all? 151, just round it. 151. Because it's really like 150.997, so good enough, 151. Okay? Equals. Now what I do is I look at the 2 different scenarios, right? Because there's a plus and minus here. 2 different answers. First one is when you take negative 60, you add the 151 and then divide by negative 32. The other answer you get when you do negative 60 and subtract the 151 and then divide by negative 32. When you do this on your calculator, make sure you do the entire top first, get an answer, and then divide. Do not do this. Do not type this into your calculator. Don't type that in. It'll be wrong. Okay? Because your calculator is going to do order of operations. It's going to do division before addition. If you're going to try and type it in on your calculator all at one time, you must put parentheses around that so that your calculator knows to do the top first. Right? Either way, let's see what we get here. Negative 60 plus 151. Enter to get an answer. Divide that by negative 32. I get negative 2.84. I already know I'm going to throw this answer away because it's a negative time. Okay? The other answer, negative 60 minus 151, hit enter. Divide that by negative 32. 6.59. Anyone else get that? 6.59? Okay. That's my answer. Not this one. 6.59 seconds. Good. You have a ball, right? On a 300-foot bridge. You throw it up into the air at 60 feet per second. It will take 1.875 seconds for it to reach its maximum height of 356.1 feet. It'll take a total of 6.59 seconds for it to come back to the ground. On Earth, that's what will happen. All right, let's keep moving. We've only done 2 problems on this review. How are we doing? We only have 15 minutes. Okay, I'm going to start cranking the rest of this out pretty fast now. Those are pretty long, tedious problems. So maybe when you come to take the test, maybe you start at the end. I don't know, it's up to you. Say, while I'm fresh and ready for this test, I'm going to start with the problem with the ball because I know it's going to take me a long time. It's up to you. All problems on this test are equally weighted. So number 1 is the same as number 7, all right? So you can kind of decide how you want to go about it. Here we go, number 1 on the review. So I give you a function, f of x equals negative 2x plus 6. I ask you first of all to find f of 3. All that means is what? Plug 3 into this, replace the x with 3. Okay, so you get negative 2 times 3 plus 6. But that's negative 6 plus 6, which is 0, right? Because you do this multiplication, you get negative 6. All right, now for part B, I say what's f of negative 2? So now you replace the x with negative 2, and now you're multiplying a negative 2 and negative 2 together. That's positive 4. 4 plus 6 is 10. And for part C, I say, where is f of x equal to negative 12? That's different, right? We're not plugging negative 12 into the function. What we're doing on that one is we're taking the function 2x plus 6, and we're setting it equal to negative 12, right? We're saying, hey, when is that function equal negative 12? And now you go solve for x. Yeah, so subtract 6 on both sides first. You get negative 2x equals, isn't that negative 18? Right? And now divide both sides by negative 2. And you'll get x is what? 9. X is 9. Make sense? Any questions? Okay. All right, number 2 is pretty much the same as number 1, except that I gave you a quadratic function instead, just to make sure you're comfortable plugging things into this. So for part A, what's f of 3? Negative 2, you have to do 3 squared plus 6. So that's negative 2 times 9, because you square 3 and get 9. Then plus 6. You multiply the negative 2 times 9, then you add the 6. Negative 12 should be your answer. So this is more about order of operations, like what do you do first, right? You do the exponent first, then you do the multiplication, then you do the addition, right? PEMDAS. For part B, I want you to plug in negative 2. Now I intentionally did negative 2 because I want to make sure that you can plug a negative into a quadratic and not mess it up. So for part B, f of negative 2 means you have negative 2, but then you have negative 2, you have to square it and then add 6. Right? That's just me replacing that x with negative 2. So order of operations, what's negative 2 squared? 4, right? So this is really negative 2 times 4 plus 6. Now multiplication comes, negative 2 times 4 is negative 8 plus 6, and that's negative 2. Good? All right, let's look at number 3. So for number 3, sketch the line. So I give you this function f of x equals negative 3x plus 6. Let's do number part B also. What is it? 1/3
X minus 4.
1/3 x minus 4. All right, I'm going to sketch both of these lines separately. So what you have to remember is that when you have a line, all lines look like mx plus b, right? So the m is the slope of the line, and the b is the y-intercept. So this tells me that at 6 on the y-axis, up 6, I have a point on my line, and then to get to another point on that line, I use this slope, negative 3. And we look at negative 3 as a fraction, negative 3 over 1, so that we can determine what the rise and the run is. The top is the rise, the bottom is the run. So if I tell you have to rise by negative 3, you're really doing what? Down 3, and then run by 1 means to the right 1. So from this point, we go down 1, 2, 3, and then to the right 1, and I draw a dot. Here's 1. And then once I have 2 points, I can draw a straight line. From this point, down 3 over 1. Do not start from here and go down 3 over 1. That's wrong. You always start from the y-intercept, and then you do your slope. This problem, slightly different. Your y-intercept is now down 4. 1, 2, 3, 4. And then to get to another point, you use this slope, which means you rise by 1 and run by 3. So you only go up 1 and then to the right 3. So up 1, to the right 1, 2, 3, like that. Right, and draw a line between those. That's it. Number 3 is done. Number 4, are these lines parallel or perpendicular or neither? So I give you 2 functions that are lines. Are these 2 lines parallel, perpendicular, or neither? Perpendicular. Why? These slopes are opposite reciprocals. So if you take that slope right there and you flip it over and change the sign, you get that. That's what you need for perpendicular. That you take one of them, flip it, change the sign, you get the other one. What would it take for it to be parallel? The exact same number. And then if it's not perpendicular, not parallel, then it's neither. So if I change this problem to this, what would your answer be? Neither, right? Because if I flip that, I get 5, but then I have to change the sign for negative 5, right? And that's not negative 5. So these would not be perpendicular. These aren't the same number, so they're not parallel. So this would be neither. And see the difference? That's perpendicular lines. That's neither, right? Yes?
So if it's 1/2, it's still going to be?
If it's 1,